It's all here. Finally, I got my stuff back. Well, here it is. This is everything. Flex plate, balancer, intake, cam, pistons and rods, all the rings, bearings, brass freeze plugs, crank, heads, block, all this stuff he had at the shop. So happy everything is home, and I'm glad that I'm able to move forward, because I was holding back, like I said, I was holding back money waiting for some of this stuff to get back, so I knew how much I had to pay, so now I can kind of move forward and buy some stuff I needed to get for a while here. So let's go through a couple different things. So the balancer is from Power Force. The first balancer I had, I won't name the manufacturer, when he put the, I had a balancer and flex plate. When I put them, well, I gave them to the machinist and he put it on the balancer crank. He was like, this thing is way off. He said, I should not have to balance this crank this much. I think there's something wrong with either the flex plate or the balancer. So I had this stock flex plate, and I had a factory stock harmonic balancer. So I took those both up to him. He put it on there, and he said, man, this thing is almost dead on with these. He said, I don't know what was wrong with those other two, but they're no good. And he said he actually has seen recently with some of the Oldsmobile stuff he's done, either the flex plate or the balancer has been off weight-wise, because these are externally balanced. So for now, I found the Power Force, and he checked that one. He's like, oh yeah, it's perfect. And it's got the laser etched timing marks on the sides, so it's kind of cool. And I've got we actually bought another flex plate, and that one was off too. So it's the factory flex plate. I don't know. I think ATI is supposed to be really on the mark, but those are a little expensive, and I don't know what I'm going to do there. So I might end up staying with the flex plate. He cleaned it up, and then he magnafluxed it, and he said he couldn't find anything wrong with it. He said it's in perfect shape, no run out. So okay, he said all the teeth look good. So all right. Anyway. So all that's done. Heads are from Edelbrock. Those are the Olds big block heads. And the crankshaft has the N casting on it. It's a nodular crank. They did make forged cranks, I think, for the 425s. Yeah, but good luck buying one of those. I'm not paying that kind of money. I didn't have that kind of money in my budget, so that's that. But anyway, so all that stuff is back. Moving over to the block. This is, I couldn't find a VIN number stamped on it, so it just got the casting marks. It is an F block. You can see the F back there. And I think the production run on these was 68 to 74, something like that. So yeah, it's in that range. It's a F block. It's not a FA or F1, it's F block. So as soon as I got it back and I put it up on the engine stand, I turned it upside down and I used my air nozzle and I just blew all the coolant passages. And this is what came out. All this trash was still kind of like clinging to the cylinder walls and inside there. So all of this probably would have ended up in my radiator or somewhere had I not gotten it out. So I'm going to do a little bit more cleaning on that, make sure I get up in there maybe with a couple of little wire brushes and stuff just to make sure all that scale is loose. And you notice the tire. When I was a young man, a buddy of mine, his dad would build engines every now and he would always put a tire underneath the engine stand. And I asked him why. And he said, you don't want this thing hitting the garage floor if the engine stand breaks. And he kind of talked about it like that was from experience. So he would always throw a tire under there. This is the only one I had. I really would like to have like an old, like 15-inch, like thick sidewall tire or something to give it a little more cushion. But anyway, that's what I got. And I've always done it with my engines when I had them on the stand, when they just sit there for a while. Just in case, because you go on the internet, you'll find a broken stand here and there, and I don't want to be one of those victims. So anyway, that's all the stuff. Oh, what's the other thing? Oh yeah, so I'm using ARP main studs, and I needed to get the block line honed. So when you do that, sometimes what will happen is down in these passages, you will get little tiny pieces of shavings that will get stuck down in there. So I saw a neat trick. The guy takes like a really strong magnet and sticks it on the end of like one of those little skinny screwdrivers, sticks it on the end of the shaft and basically kind of magnetizes the screwdriver. And he kind of just works his way down in there. And I saw on the video he was doing, he actually pulled a little curlicue piece of shaving out of one of the galleries, out of one of those mains. So I'll do the same thing just to make sure it's all clear. Blow it out, then I got to degrease it. I will probably run a die grinder over all the edges and kind of deburr it, and then get a coat of high temp engine paint on it, some engine primer, and then we'll be ready to go. Anyway, that's everything. I'm very happy. So I'm glad everything is back. So we'll start at the back of the block first, get these done, and that way I can put it back on the engine stand and I'll do the rest there. Makes it a little bit easier, but these I just need to take the back off to be able to get it. So on the back of the block you have two casting or freeze plugs and then also two pipe plugs. This one back here, submerged inside here as you can see it, that pipe plug has a 20 thousandths hole in it, and that squirts oil onto your distributor and keeps that thing in line so the gear doesn't burn up. And then the other side, the pipe plug is right there, and it just goes in, and that's where the oil galley is on this side. No big deal. So let's take a look at that pipe plug. So there are the two plugs. The red in color one, that one goes on the inside, and that's has your squirter hole in it. 20 thousandths hole. So if for some reason you get a block and it doesn't have this, I believe these two, the pipe plug on the bottom here that goes on the other side, I think there's two of them that come in the plug kit. So you can buy a 20 thousandths drill bit, or if you have one, just center punch and drill a hole out in the center of this and put it in place of that, and you should be good to go. So let's get these in. Thought this might be the best vantage point for this one. So I had to run out to the hardware store, and I picked up some 5/16 square stock, just like bar stock, which ends up fitting in here perfectly. And now put a little Teflon tape around the plug, and now it's just a matter of getting it in the hole, getting it started, and tightening it down. All right, with that one in, we can now put in our standard pipe plug in the back. All right, that one is in, using a 15 millimeter socket, which fits just inside the cup. Let's line that up straight, drive her in. So I'm not sure if I mentioned this, but I use just the tiniest little bit of black silicone, high temp silicone on it, just to kind of help it, give it a little bit of a seal when it goes around. Use what you want. I've seen people put them in dry, and they say that's the only way they should go in. Seen people use aviation, like that gasket maker, the brown stuff. Whatever suits you, this suits me. All right, level that up and drive her in. And my camera cut out, but you get the picture. With the freeze plugs or core plugs, whatever you want to call them, in place, and with the pipe plugs in, now I think what I'm going to do is I'm just going to degrease and clean up the back of the block here, and I'm just going to paint this area just to keep any surface rust from creeping in. And I think the block is going to be like that Oldsmobile blue, but I think I'm going to paint the back of this like a cast coat aluminum color, and that way get any leaks or anything back there, because the bell housing will from the transmission will be bolted on, so you'll have limited view up in there. Any leaks or anything weird should be very obvious where it's coming from, because it'll be a silver background. Anyway, no one's going to see it, so who cares, but I do. So let me get that cleaned up. So with 3 coats of some Duplicolor engine primer, and then another 2 coats of the Duplicolor cast coat aluminum, number 1650 if you're looking for it. That is all buttoned up. So I like the way it turned out. And honestly, no one's going to see it. I just wanted to do it just to kind of knock down any scale or rust that would get on the back side of it. Plus, if I haven't, like I said, if I get an oil leak or something out there, it should be readily visible with being kind of a silver color. So let me get it back up onto the engine stand and we'll get moving from there. Now I'm not sure if you're going to be able to see this camera-wise, what I'm doing here, but I was taught this a long time ago, old-timer trick. Because the cast iron is so porous of a metal, a lot of times you get it back from the machine shop, there's just like from lots and lots of hands on it and use, cutting and everything, and just it's an oily mess. And as much as you try to clean it, it's difficult because there's so much oil and grease and stuff that can soak into the cast iron that you sweat it out of the block using a torch. Now I want to see if you can see the line. You see that line start to appear, right? So as you heat the block up, you start to cook all that grease and oil and stuff that is soaked into the cast iron. And then you just follow that wave on down until you've gone around and done the whole block. Now what this does is leave you with a very dry surface that's ready to go. So I'm not going to sit here and bore you with this, but I wanted to show you this is something you can do, especially with cast iron. It's so beneficial to just kind of sweat all the oil and grease and all that crap that gets in there out of the block before you do your final clean and prime it and paint it. So anyway, I'm going to do the rest of the block, and then I guess we'll mask it off, and then we'll get some prime and paint on it. Cool. Just wanted to show you that. Everything is ready to go. I got my primer, same 500 degree primer I'm going to use, so I'm just going to grab that and just start spraying this down. You need to do light coat, wait 10 minutes, another light coat. It says 2 light coats and then a medium coat. I'm going to do 3 light coats in a medium coat. I want to get really good coverage with the primer. I want to make sure that I got everything good and covered, and then I'll move on to the Oldsmobile blue if I have time, if I decide to do it. So I got everything taped off, ready to go. It's clean. I'm going to try not to touch anything, and let me get my respirator, and I guess we'll start spray painting. Okay, so that is one good light coat over the entire thing. Now I'm going to wait 10 minutes, and then we'll come back, do another light coat, 10 minutes, come back, do another light coat, another 10 minutes, and then we'll come back and we'll do the medium coat and make sure I have really nice coverage over the entire thing. Just want it to be very uniform, and I want really good coverage, and I'll keep spraying until I feel I got that. If it has to go more than 3 light and a medium, but I think I should be fine. Anyway, to you it'll be a second. For me, it's going to be like 40 minutes. I'll show you what it looks like once all the primering is done, and then we're ready to go to color. So see you in 40 minutes. Just a second. 4 coats later, and I got nice coverage on the primer. So with all that done, now I can move on to color. So this is what I'm going to use. This is from Thornton, and it is the 455 Blue Metallic Engine Enamel. And as you can see, it's certified General Motors restoration paints. I did a spray out with this just to make sure that the compatibility with the primer didn't have any issues, and didn't. Everything reacting fine, so this is going to go on. This is the stuff I'm going to use. I have found a bunch of different Oldsmobile blues, and some of them just, I don't know, the tone just doesn't look right, and so far this is the one that I have found that for me looks the closest to what I feel the Oldsmobile blue should be. So this is what I'm going to use. So same procedure, coat 10 minutes, coat 10 minutes, coat 10 minutes until I got full coverage. So that is what's going on. And final result, 4 coats of primer, 4 coats of color. I think she turned out beautiful, and I'm glad it's covered in paint now, so I don't have to worry about any flash rust or anything going on with the block. So now that that is done, I'm probably just going to wait till tomorrow, and then I'll just start peeling off all the tape and everything, wrapping it up. All right, like I may have told you before, when you get your engine back from the machine shop, if that's where you sent it, you're going to have to clean. There's going to be a lot of grease and other stuff that's just penetrated into the metal just from everybody handling it so much. So I've got some cleaner, and what I'm doing is, before I get the crankshaft in, just so I don't brush any debris down onto it, I want to clean all the cylinder walls nice and clean. Get the top end done. Do the same thing with the lifter bores, just to make sure everything is clean. That's what comes out of your cylinder walls. Now I want you to watch something. Do this again. Fold it over, clean portion. Wipe the same cylinder. All right, you can see that there's a little bit more. We're just going to keep folding this thing around until we get no dirt, grime, whatever you want to call it, on the towel. Okay, a little bit more. Just going to keep rubbing this down. Trust me, this is going somewhere. I'm not just cleaning for the sake of cleaning on camera, because there's nothing exciting about this. Okay, so I've got it down to there's almost nothing, right? So one would think, hey, I've cleaned it and then re-cleaned it and then cleaned it and re-cleaned it, so it should be clean. Think again. This is Marvel Mystery Oil. This stuff has been around since sometime after World War I. It's used in engine oil and in fuel to help clean components. This stuff, in fact, the guy who made it, when was asked what the formula was, he said, well, it's a mystery. And the name stuck, and that's what he used. But this stuff is, it's almost like transmission fluid. It's like a real lightweight though. So I'm going to do the same exact cylinder. The one I just cleaned completely, 3 or 4 times in a row. So we're just going to do same one, see what we get. Look at that. I don't know if you can see that. It's turned it brown. This stuff, you can do the same thing with transmission fluid. It just has a lot of detergents, I guess, that's in with the makeup of this. And it just does a really good job of scrubbing components. You can use this in your fuel and it'll clean the valves and all kinds of stuff. So fold this around. I'm going to hit it again. So this is twofold because now I know that the cylinder is very, very clean because I've gotten every little bit that's in the crosshatch of this. I know it's completely clean. Plus now this stuff is on it and it's a preventative from any moisture or anything getting to it. Look at that. Still pulling dirt out. This stuff is really, really good. Been using this since I was a kid for all kinds of stuff. In World War II, they used it in tanks, ships, planes, for engine additive and fuel additive. This stuff has been around forever. And it's still around because it works. Anyway, I'm going to get to cleaning the rest of these. I just thought it'd be something interesting you could do. If you're cleaning up your engine, one last step before you're done. Once you use whatever solvent you're going to use to clean everything, go back with some Marvel Mystery Oil or use transmission fluid a little bit on a rag, but gets everything like deep cleaned. So just wanted to bring that up. I'm going to finish the rest and then we'll flip it over and then I'll show you what I'm going to do for the crankshaft. So as part of my cleanup procedure, not only do I clean the external side of the crankshaft, but also all these cross-drilled oil passages. I'll grab a pipe cleaner and I will spray a little cleaner through there, and then I'll run the pipe cleaner through there. And the whole point is to try to catch any dirt or debris. What I'm really looking for is any type of metal shavings from when the crank was turned or polished. You want to make sure that, like in this passage, if a little chip gets up in there, at some point that's going to flow out into your oil passages if you don't catch it here. So make sure that you clean everything. I'm on my second pipe cleaner. This was white. This was the first one. So I'll do that a couple of times, clean it down really well, and before I ever think about putting it into the block. Let's get this baby flipped up the other way. There we go. All right, the block turned over. I am ready for bearings. So you've got, on this particular type, 2 types of bearings, 2 different shells. So you've got a smooth shell on the top and you got a grooved shell on the bottom. I guess the bottom when looking from this direction, this is actually the top when the block's upside down, right side up. So anyway, so there's an oil feed hole here. That has to line up with this hole here. This is the top or the bottom that goes in the cap. So we'll sit those off to the side when we get to them. And let's see if you can see this. So there is, see that little tang right there? That's what I call it. So there is a groove in the block in the saddle, and that fits into that groove. And that lines that up. So what happens is when the cap goes on, the cap covers up that little tang and it keeps the bearing in place, top and bottom, because there's also a tang on the top one on the opposite side here, and it keeps the bearing from spinning in the saddle. If you've ever had a spun bearing, no one likes that. That's no fun. So you don't want that. So let's get the rest of these in. This is the thrust bearing. You can see it has this thrust face on both sides of the bearing. On an Oldsmobile, that is in the number 3, and you'll actually see it because there is a machined groove on either side for this thrust surface to fit into. The rear main has stamped on it upper and lower, so you have to make sure you get those right. Since the block is upside down, this is technically upper, so all the saddles are your upper and the caps are the lower. So we got to make sure upper, got that right. So that goes in your rear main. All right, let's get some oil. All right, so this is just some 5W30 oil. Let's get this in here. Get it nice and lubed up. Try not to touch these bearings with my bare hands. Don't want to get any oils from my fingers onto the bearing surfaces or any sweat or anything that's going to keep the oil from going where it needs to go. Now, if you're observant, maybe you're saying right now, Hutch, you're getting ready to put the crank in, but you didn't put in the rear main seal. Well, I'm not going to put it in just yet. What I like to do is put the crank in. I like to get everything torqued down, and I want to see how well the crank moves. When you put the rear main seal in, it provides a certain amount of drag. And what I want to see how well the crank moves without any type of limitations on the rotation. So it's more work because you got to put it in, torque everything down, spins fine, everything looks great. You got to take everything apart, take it back out, then put in your rear main seal, and then put it in for good. But that's what I like to do. I just want to make sure that the crank is going to spin without any type of limitations. For this build, I am using ARP main studs, and these are best put in finger tight. There's no reason to torque this down. That is not where your tightening yield is coming from. So a lot of these holes where this is fitting into, they're open at the bottom, but there's a little cast ridge on there, so it can only go so far. So when it goes down, like right there, I can feel that that's the bottom. That's it. It's finger tight. It is all you need. There is an Allen fitting at the top, so you can use, I guess if you had to zap these out, you could put like an Allen socket on it and get them out. I try not to do anything crazy with these things, just because I don't want to create any more problems than I have to. So everything, when it comes to these, I put them in by hand. So let's throw the caps on. We're going to start with our thrust. See if you can see this or not. You can see that number 3 on there. That number 3 is always going to be upside down. It's going to be on the passenger side. Also, the tangs on this side, they're both going to line up the same. And these studs are actually about, I don't know, maybe 100 thousandths. They're actually off center just a little bit. So it's relatively impossible to be able to put the cap on any other way except the right way. Number 1. So number one bearing has no groove. Number 1's by itself. Just one groove on the bottom, top is solid. Two. Four. And then the rear main. This is a lubricant that comes with the main stud kit. It is Moly Lube, and in order to get the recommended torque spec, every surface has to be lubed. Everything that could possibly cause friction. So the studs themselves, the landing that the washers go on, the washers both sides, everything needs to be lubed up so we can get a proper torque spec. So everything gets a washer. And then the same thing again. We'll lube on the washer too. All right, so we're going to snug down number 3 here. Let's take it up to 80. So now we'll back that back off. There we go. All right. So let's beat on the crank a little bit. So what we're going to do is I'm setting the position of this one cap, where the thrust bearing is at. So I'm going to spin it, drive it back, and then we'll spin it and drive it forward. That'll set it perfectly in here. And then we'll just tighten the rest of them down. It should be good. Oh yeah. And the same thing going forward. Now we just torque them down. Let's get them all snugged up. All right, let's do our increments. Now it was 50. Let's go 80. Final torque, 110. Need a little bit of brace on this. There it is. Now with everything torqued down, this is what you want. Look at that. Just as smooth as butter. Ah, I love it. Here's the thing. You put that rear main seal in, especially if you're using like the old rope seal, even the 460 Ford neoprene seal, it puts drag because of how it seals on the back of the crank. So it makes it a little bit stiffer. The crank won't glide like it does now because of that resistance. So it's probably unnecessary. I mean, I got it back from the machine shop and the guy is really good and he does phenomenal work. So I trust what he did. But like George Bush said, trust but verify. So here I am. I do this on every engine build because honestly, I got all the time in the world. This is the one thing you don't want to rush is putting an engine together and have something go wrong. So I take it one step at a time. I'm very meticulous and I'm slow. Same thing when it comes to putting in pistons. I'll do like a front bank 1 and 2, and then I'll go inside and get something to drink or just relax for a second, and then come out and do another 2. I never try to rush and do it all at once because I don't know, stuff like this, you just make mistakes. It's probably unnecessary, but it's how I've always done it. And this is one of the things. I want to see that the crank just, look at that. That's what you want. It's beautiful. Now, I did all that work. Everything has to come back apart. Crank's got to come back out. Seal's got to go in. And then it'll be in there for good. All right, well, let me get everything disassembled and I guess we'll put that rear main seal in. If you buy an Olds gasket rebuild kit, it's going to come with this. This is the, 1960s technology rope seal. You basically jam it into where the seal goes in the back and then you cut the ends to make it fit. No, we're not doing that because there's a better solution now. We have, someone has, figured out that the Ford 460 big block, the seal diameter, everything is exactly the same. This seal fits and works perfect. Now, what I understand is, you can see that little ridge. It is just a little too thick, and it actually puts a little additional squeeze on the rear of the crank. So to relieve some of that, this is what I've heard, is you basically just take a razor blade, and there's a metal spine in here, and you're just following that, and you just take off. How am I going to do this so you can see? Let's see. Can you see that? So you just follow it along, cut that little ridge down a bit. Now, remember, with a razor blade, what's the saying? Don't get bloody, cut towards your buddy. So try not to cut at yourself when you're doing this. Okay, so now that little bit has been shaved down just a skosh, and that is enough to make that seal fit perfect. Now, here's the second thing. Let's get up here. You can see there is a lip on the inside here. This lip, when it goes in, this is the back side of the block. This lip has to face in toward the engine. All right, so basically what happens is the oil pressure goes into this cavity and it pushes the lip up and into the crank, which makes your seal. Make sure when you're putting it in that lip, see how it is? You know, actually this way to show it really well. So you see that little lip that's there that has to be on the inside. So when the oil hits it, it spreads that lip out and it actually grabs the crank. Helps to seal it. You put it in that way, gush, it's not going to work. This has got to be toward the engine. So we'll do the cap first, groove toward the engine, and then we're going to use the tang side. So I'm going to have this up. I'm actually I'm using a drill bit to kind of make sure they both have the same level. They'll kind of push themselves into place. I always do this. I overlap the seal so that way the parting line is actually inside the cap and not right here at this surface where you could possibly get some type of leak. I think it even says that in the instructions. For 460, of course, but it says about 3/8 up on either side. So I know it's up on this one, so it needs to be down on the block. So let's move this out of the way. Same thing, making sure our lip is on the inside. Down there. Same thing, use my drill bit. I kind of get it as close as I can to about the same. Perfect. Now, since this is going to sit for a little bit and you also want this thing to be able to rotate confidently without worrying about, because if I use thin oil on this, it's like 1530 I think, because I wanted to see the rotation. I wanted to see it move. I wanted to make sure that it rotated smoothly with no obstructions, and it does. It's beautiful. So now that it's going back together and it's not coming apart, it's going to sit for a little bit. So what I want to do is actually use some of stuff goes on like honey. So this is Permatex Ultra Slick. So I'm just going to lube all these surfaces so that way this stuff will cling to where it needs to. Won't run out any passages. Get out of there. And it'll just stay nice and slick. Because I don't know, I'm still waiting on some other parts to come. So I'm trapped by the coof. I don't know what it is, but man, getting Oldsmobile parts now is it's not fun. I think they're too busy building Chevy stuff right now, and they're not concentrating on some of this off-brand stuff. So I'm also going to paint this out so it's nice and slick when the crank goes in. Perfect. So I'm going to do all the bearings like that, and I'll do the cap same way. And then we'll be ready to put this back together. So when the rear cap goes on, this is something I do, just gives me peace of mind. I take a tiny, tiny little dollop of black RTV, just a scocious little bit, and I just give a quick, thin wipe around the mating surfaces. Barely enough to even be seen. Just enough to give it a little bit of kick when it goes on. All torqued up, home for good. Now, with the seal in and with this super thick assembly lube, look how it spins now. Right? I mean, it's got resistance, but it spins smooth, but there's so much resistance from the seal in the back plus the heavier assembly lube that if you had a binding issue at all, you may never find it till you crank her over and start it up, and then you find out you got an issue. So that is why I do the 1530, torque everything down and spin her and see how she is. So I like to know that ahead of time. So all right, so now we got it good and lubed up with assembly lube, and that stuff is going to stay and cling right where it's supposed to, and I'll be good because I got to wait on the camshaft. And oh, you may notice, what are these studs here for? Well, I'll tell you, the studs are here for a Mylodon oil baffle. This took 11 months to get to me. 11 months. And yeah, that's why this video is like 2 weeks late, because I was was going to go ahead and put everything together, and then when the thing finally showed up, I was just going to back out those specific studs and then put it in and put it back together and maybe show like a little short video. Hey, I got it. But then right when I had finished putting the crank together and had it oiled up, spinning it, it was late, so I left it there, and I was going to start filming the next day, finish it up. And I got an email, and I was like, hey, your part's just about ready. It's on the way. I'm like, sure, I've heard that before. I've gotten 7 notifications that next month it'll ship. And then next month came around, and I got another notification, and next month. And then it just went like that for 7 months straight. So, again, I don't know. Blame the coof. I don't know what it is. But it's here. And you know what? I went online because I thought, the stud kit came in before the baffle did. And I thought, oh, you know what? I'll just install the studs. And then a later video, I'll show putting this on. And then like right behind the studs showing up, I got the email that this was going to be coming out soon. So I just waited. But I went online. I could not find a single solitary picture, video, nothing of how this thing sat on the mains, like which ones it went on, right? Was it 2-3? Was it 3-4? I wasn't exactly sure because there's no scale when you're looking at a picture. It's just a picture online on the Mylodon website, so I don't know. Anyway, so I figured I'd just wait until the thing shows up. Funny thing is, when it showed up, it came with instructions. At the top, it said Olds 350, 455. So it's meant for this engine. And it said to put the studs on 2 and 4. And so without even looking at the thing, it was still in the box. I put the studs in 2 and 4, and I was going to test fit this. And I put it on, and I'm like, wait, that's wrong. So it's 3 and 4. So even their own instructions were a little bit off. Anyway, there it is. Let's get some of these parts out. So I'm messing with the oil pump today. So I have a Moroso oil pan that I'm putting on the car. And I'm also using a Moroso pickup that's supposed to match up with that. Where's it at? It matches up with the pan. So let's get this out. This is the sealed power Melling. I think they're all probably the same. It's a standard, it's not a high volume, it's a standard oil pump. So let's talk about that for a second. So you've got, if you know anything about Oldsmobiles, you've got an engine that has less than ideal, let's put it that way, oil return. It's just, I guess, the passages coming down from the head into the block and back down. It's just it's a pretty small hole on both ends of the head, front and back, and with the engine, of course, being tilted back a little bit, most of the oil collects at the back. So there's all kinds of stuff. People have been putting restrictors in them to keep more oil down at the bottom of the engine, and doing different things to plumb the oil different ways to get it back. I'm going to try something different here. Well, honestly, this isn't different. This is just what I'm going to do. Let's put it that way. So you get, you have an engine with less than adequate oil return. And then guys put high volume oil pumps on them. And they're like, oh, it's terrible. All the oil stays up at the top and my valve covers leak. Well, yeah, you're pumping a ton of oil up to the top of the engine, and it doesn't have a chance to flow back because you just keep pumping more oil because you're using a high volume pump. I am using, this is the M22F. It's a standard volume oil pump. This is more like what you would get on a stock big block, small block Olds. So it comes with this pink, purple spring. And it comes with some instructions. So basically, the oil pump supplied with a pressure release spring that is equivalent to the OE design. If a higher pressure, approximately increase between 8 and 10 pounds is desired, remove the green spring and replace it with the pink spring. So that's what I'm going to do. I'm going to put in the pink spring, and I'm going to increase the pressure of the pump, but not necessarily the volume of the pump. I don't think you need to pump a ton of fluid up to the heads if it's not going to go back. And then you're just going to have, you're going to have the same issue with what you're trying to restrict the oil from getting to the top in the first place, is that you're limiting yourself on the amount of oil that is in the bottom of the pan, because it won't flow back because you're pumping it out faster and it'll come back. So I think, I mean, these cars, these engines have been out since like the mid-60s. And I've found nothing online about Oldsmobile engines blowing up or burning up back in that time frame. And this is back before, you know, all this stuff became an issue. Guys were just buying the cars off the lot. They'd buy a 69 442 and they'd take it to the track and they'd run it. And I wasn't hearing anything about there being a huge issue. Tell me I'm wrong. There's a comment section down there. You know, this is my first Oldsmobile engine, but I know how to look stuff up, and I can't find anything saying that there's like some super huge problem back when these cars were new in the 60s and 70s with this stuff burning up or freaking out. I don't see it. Maybe it's there and I just haven't found it. I don't know. Anyway, let's put this spring in. So you get the spring and you get a new cotter pin. So we're going to take the old one out. Everything else that's in here we're going to reuse. So we'll get this pulled out. Notice I got my thumb over it so this thing doesn't fly away on me. So this little guy, which is the retainer for the spring, that stays in there. So we're just replacing the spring. That's it. Make sure that seats in there the way it should. That goes back on. Then we'll just pop this down to the point that this, so we get this in there just enough to get it started. Come on. There we go. All right, cotter key goes back in, and then we just bend this over. Yeah. There. And that's literally all I'm doing. So now, just get our pickup on. So in order for this to go on, this bolt has to come out. And there is a longer bolt that comes with the pickup. So we'll set that off to the side. Let's see. Let's get our bolts out here. So you've got longer bolt. You've got a spacer that's going to fit in between this the plate and the pickup, and then the lock washer to go with it. So let's get this relatively, that's about right. So now we just have to get this bad boy on. Get this thing turned around so you can see, and we'll get our bolt in. A little bit of blue thread locker to go on this, and our lock washer at the top. The old bolt was 3/8, but the head on this one is 7/16. Let's see if I can get in there with this thing. Wasn't that tight to begin with when I took them off. So now it is on. The question is going to be with the pickup like this, like your ordinary pickup you would have on the car. Basically, you'd drive it in, and you would have marked it ahead of time to the depth of the oil pan versus the depth of your screen to make sure that the thing went in and was at the proper depth, and you could move it around. With this, it actually bolts to the housing of the pump. So you probably got a little bit of wiggle room as far as this bracket, but not much, not much. So this is supposed to match up with the oil pan that I have. We're going to find out, because next time you see me, I'm probably going to put this on the car and then check the depth of this versus the oil pan just to make sure everything is good. First things first, let's check our pan depth. So I'll get a flat edge or straight edge across there, and then we'll just check with a tape measure. And that is right at 8.5. So you want the pickup depth to be anywhere from 1/2 inch to 3/8. So if I can get a comfortable 8-inch out of the pickup, that'll be a 1/2 inch difference between the pickup and the pan. That should be good. So let's see what we got. All right, let's get this pump on, and I'm using the bolts from the 307 that came out of this. I've actually got new bolts on the way, but this will work for getting this in and getting the measurement. I actually talked to Moroso. I called their tech line, and I asked them, what happens if this thing isn't like in the depth range that I think it should be? And what he said is that this is designed to be anywhere from 1/4 to 1/2 inch in depth between the bottom of the pickup and the bottom of the pan, which is different than what I'm used to, but that's what they designed it for. He also said you're probably going to notice that the pump is going to sit at a bit of an angle. So he said you measure both sides and then you calculate the difference. So sure enough, with the straight edge on that, you can see it is at an angle. So let's check one side versus the other. All right, so this is what I'm used to. This side is right at 8 inches. So that would be your 1/2 inch. When we go over here, it's 8 5/16. So that's a bit of a difference from side to side. So he said you measure both sides and you take an average, and the average actually comes out to 5/16, which is very close to 3/8, and he said anywhere from 1/4 to 1/2 is what you're looking for. So, all right, I'm going to go with that. So anyway, I'm going to take this back off because I'm not going to have this on to get all the rods and everything in, but I just wanted to check the depth versus the pan to make sure I'm on target, and apparently according to Moroso, I am. So that's one side done. Let me turn this around, and we're actually going to look at getting the camshaft in. Now we're ready to make a mess. All right, so I have completely cleaned the camshaft. because a lot of the stuff is going to be packed in some type of grease, something basically just to keep the surfaces from flash rusting. And what you don't want is all that stuff going into the engine. So you want to get everything as clean as possible. Oh, this stuff is messy. It's also a good time to make one last clean on the cam bearings. Make sure everything is just sweet. All right. No sense rushing this. You don't want to smack any of the cam bearings with the camshaft while it's going in. So take your time. There's no rush here. All right. Get it to the next bearing and lube some more. Wish I had a longer bolt, but I don't. Couldn't find one with the same thread. I'm just using the cam bolt here and a socket to give me a little bit of leverage. All right, one to go. All right, she's in. So this camshaft is from Howard's Cams, and it is a 4/7 swap. And in case you don't know what that is, I'm going to try to draw this for you real quick. It's kind of crude, but this is your engine. All right, so you've got 1, 3, 5, 7, 2, 4, 6, 8. So there are your 8 cylinders. Distributor is back here, and let's put these in. That's kind of crude, but there it is. So if you're an engine guy at all, probably out of the crib, you will have remembered 1843657 That is a firing order on a V8 engine. And honestly, except for Ford, I said the F word, but except for a couple of manufacturers, I think Cadillac was the same, a lot of the V8s were 1843657. So on an Oldsmobile, you've got counterclockwise rotation. And number 1 is right there. So normally it would be 1843657. But we've got a 4/7 swap. So it is 187 3, 6, 5, 4, 2. So that is the firing order. So basically what you're doing is you're swapping the spark plug on number 7 and number 4, and you're switching those. Supposedly, I think it evens out the ignition pulses. I don't know, but they do it, and I think it's already been proven there's not really a significant horsepower change between the two. But be that as it may, that's the cam that they sell, and that's the one that I bought. All right, let's put this oil baffle in. That little guy there is to keep oil from slinging up and coming up inside your fill tube up here. So let me get this down here so you can see it. Okay, these are the pipe galley plugs that go in the front of the engine here. Now, let me grab two and put them side by side so you can see. If you can see, one is taller than the other. The taller one comes from the 307 that I took out of the engine. The 307 has had a roller, hydraulic roller camshaft like I'm putting in here. So it had a plate that bolted to the front. That's why you needed the longer galley plugs to make up for the thickness of the plate. That plate was there as like a thrust plate, and it kept the camshaft in place. I think on normal hydraulic flat tappet cams, the lifters, the way they're designed, kind of almost pull on the lobes to keep the camshaft in, but on a hydraulic roller, there's nothing like that. So the cam wants to come forward and come out of the engine. So you'll see there'll be like cam buttons like that go on the end of the bolt that kind of make up that difference and give you your run out or your thrust distance in the front. But this has that plate, so I decided to use that plate until I found this guy. There is a dude, Clark455, on ClassicOsmobile.com. It's a forum I'm a member of, and he made this out of like a strong, like bronze bearing material metal. So, and he also redesigned it so that the thrust is a little less than on the factory one. I think he said he found up to 30 thousandths of end play on the camshaft with the factory one, and he said the Rockwell hardness wasn't as hard as this material. So this is what I'm going to put in order to keep the proper positioning of the camshaft. So I've already cleaned this thing up, and I've got a light coat of oil on this. So let me get this guy in. So they tell you, hey, make sure that you put the pipe plug with the, what is it, 20 thousandths, 30 thousandths hole in the passenger side. But in actuality, they're two different sizes, so you have no choice. Unless you mess up and don't put one in at all, that's going to ruin your day, I can tell you that. So if you've never built an Olds engine, I'll go ahead and tell you there is, like I said, 20, 30 thousandths hole in this one pipe plug. So as the oil makes its way up to the front of the engine, this hole here spits out oil onto your timing chain and keeps the front lubed. Just like that plug in the back keeps the distributor gear lubed. So I looked up a torque spec for this and I couldn't find one. So what I'm going to do is I use blue Loctite on the two plugs, and I'm going to use the precise German measurement of good and tight. There you go. Cam is in. Now let's get the timing chain. Here's a timing set. It's a Cloy's True Roller. What is that? Part number 9-3113. Now, Mayo has the exact same part number, but without the dash. And it's the exact same, it's the exact same thing. So they're both made the same. Now, let's see if I can get up here and show you this. So this is keyed, where you can put it in at straight up 0, or you can have it negative 2 degrees or positive 2 degrees. And that's what these marks are all about. So this one is the circle. Let me see that. So the circle, that is straight up. And then you've got this rectangle over here, that is 2 degrees retarded. And then the triangle is 2 degrees advanced. So when you would put this on, you would basically line up your keyway with the opening, and you want wherever you're going to set your timing, that mark is going to be straight up, so it lines up with your cam sprocket. So I am going 0 straight up on mine. So get that on, and then now we'll grab the chain and the sprocket. All right, let's get her on. Let's see if we can't get that lined up as best we can before we get her in. All right, there she is. All right, so I marked the one alignment dot. Just took a Sharpie and put the little dot on there just so you can pick it up better on the camera. So if you're doing like I did, I had to have the main bore, because I was using the studs. It was a line honed. Sometimes that can push the center line of the crank up just a little bit, because basically what they do is they shave a couple of thou off of every one of the caps, and then they put the caps on, torque them down with the studs, and then they align hone it back to its factory specification. So sometimes that'll move the crankshaft up just a hair in the block. And if you had like a Chevrolet, because you can go buy parts at the 7-Eleven if you got a Chevrolet, they make an actual chain that has just a little bit shorter of a chain to make up for that. So so you wouldn't get slop in the chain. Now this is actually this is very, very tight, so I'm happy with that. But if you've got just a little tiny bit of slack in the chain, what you want to do is, because the engine is going to rotate, all right, you want to make sure that you're on the correct side. So you want to move the crank in the direction of the rotation to make sure that your dots line up. So as you can see, Dots line up perfect, so now all I got to do is torque down our cam bolt, and the chain is in and good. Same blue Loctite. And we'll just crank this down. And you'll notice the eccentric is not going on because I'm using an electric fuel pump. Alright, now we just torque this down to 65 foot-pounds. Got my rubber dead blow mallet in here, keeping the crankshaft from moving. Until we get this torqued down. We'll take our oil slinger, put that on so we don't forget. One last thing. This was on the 307. This is basically, it's like a plastic cam button. A little spring, and this fits onto the bolt that goes in the sprocket. Now, what I understand is, and this was on the 307, so I'm going to put it on this, because if it was on that one, it didn't have an issue, and that engine had like 50,000 miles on it, ran like a top. This is supposed to, in theory, cut down on or reduce the harmonics from the camshaft at idle and just off idle. Does it? I don't know. But there's some dude who went to college for probably 6 years and did an internship and then worked his way up through the ranks in General Motors to get to the point where someone designed that thing. And if that guy thinks it's okay, then yeah, I guess it's okay with me too. Quick word before we get started. Jason commented on the camshaft video. He's an old guy. And he said, hey, I think you're supposed to use the eccentric on the cam sprocket. I think assumably it acts like a large washer for the bolt. Before I put the sprocket on, since the camshaft bolt is a little bit long, I ran it all the way down with just the camshaft and then bottomed out inside the camshaft. So I knew with the sprocket on I was going to have enough room to be able to torque it properly without bottoming out in the cam. So that's what I did. But after he said that, I was just like, let me check. So I go to the Google machine and I can't find anything that says that you have to use the eccentric on an Oldsmobile application. I can't find anything that says you can't. I can't find anything at all. There's nothing really written about it. So it cost me nothing but like 15 minutes to clean up the eccentric, take the bolt out, put the eccentric on, mold blue Loctite, put it back down, retorque it. So I'm not taking any chances, and thank you, Jason, for that comment, because it made me scratch my head and look, and I would rather have that on. It's not going to affect anything. It's supposed to be there anyway if you're using a fuel pump, mechanical style, so it's not costing me anything but a little bit of time, but it's given me a lot of peace of mind knowing that it's not going to be an issue. No one wants to tear the front part of their engine apart, ever, if you don't have to. So anyway, I decided to put it on. Thank you, Jason. All right, let's get to the video. Piston rings. Let's take these out, take a look. I like this because everything's individually packed. First groove, second groove, and then third groove. Can't get it mixed up. But even if for some reason you got these switched around, because they're chromoly, this is second groove. Second groove, regular ductile iron type ring, and then your top groove has the chromoly edge. So can't really mix them up. So the rings have a chamfered edge on the inside. You'll notice when you get them. There's also, you can see it, a dot This dot faces up in the cylinder. So can't get that wrong either, as long as you paid attention. This is our number 1 cylinder, and here is the ring. So we're going to get this ring positioned in here. And we're going to use a tool. So we bottom this thing out, not bottom out, but we put it down in the cylinder, appropriate depth. Check it at a couple of different spots. It's only 3 points of contact. So with the ring down in the bore, we check it with the feeler gauge. That is a very nice snug 23 thousandths. So the manual calls for anywhere from 20 to 40. So I'm on the tight end of that, which is good. If you don't have the spec for some reason, you can always use the calculation, which is you measure the size of your bore and then you multiply that by 4 thousandths, which is 0.004. That number will give you the closest ring gap you can have. It doesn't give you a range like in the manual. When you look, it says 20 to 40. So if you're somewhere in there, you're okay. But it will give you the minimum amount of clearance you can have. If you do that calculation based on this bore, it is 17 thousandths. So I'm at 23, so that's pretty good. And I put all the rings in, all the different cylinders, and they all come up the same. They're 23. These are not file fit. These are just standard rings. Take them out of the package, put them on your piston, put them in the car. I check every single one. So let's talk about stacked tolerances. So stacked tolerance is when you have multiple things that are made in different times and then they have to fit together. So the machine shop had a tolerance for boring this out 60 over. And then there's a tolerance after that for the final hone to get you to your actual size. So that could be off by what, 1,000 maybe between one cylinder and the next, just by the way the cutting tool works, you know. So you have the same thing with rings. All these rings are made to a specific size, and so far they all check out 23 thousandths. But I did have cylinder number 8 and then cylinder number 5 and cylinder number 8. 5 was really snug on 23 thousandths, and 8 seemed like it was a little easier on 23 thousandths. So what I did was I took those two rings and I swapped them between the cylinders, and now they're both about the same type of snugness. So I like to do that on everything. It's probably not necessary. You're talking thousandths of an inch, and I'm well within the spec range, 20 to 40 by what the book says. But I still like to do this. And sometimes when you overbuild or overcheck things, when you're putting it together, you end up not having to rebuild or recheck things later on. So that's how I do it. That's how I've always done it. I'm going to do every ring like that, and then every cylinder goes in its own little baggie. So when I'm done, the top ring, the second ring, and the oil rings will all be specific to the cylinder they go to, and that way I know everything is up to par as far as I'm concerned. Let's go ahead and at least get the first two pistons in so we can check that cam. All right, so let's do piston number 1. Get our rings out here. All right, this bad boy on first. It's our oil control ring. And I'm going to put the split on that right in the middle of the skirt. And then we've got our two oil rings. Just fit these in. So I put the control gap, like I said, center of the skirt, and then I do the gap on the bottom and upper rings on opposite sides of the pin. So that's that side. Let's do this one. All right, that feels good. And then we'll go to our second ring. This is like the oil scraper, the oil control ring, the oil scraper ring, I guess is what you would call it. So just gonna make sure that my dot is pointed up. You can buy these pliers that like spread out. You basically, you put it in where the gap is, and when you close the pliers, it spreads it out. But these rings are a bit on the fragile side, and sometimes you can snap them doing that. So I find if you just take your time, put it in slow, you can fit this bad boy in without too much problem. There we go. Put that one on the skirt over there. And then we'll do our chromoly top ring. Make sure our dot is on top. Okay, now I still do this. I put the top two rings and I stagger them on either side of the skirt. I'm going to be honest with you, and here's the truth of the matter. These top two rings, the whole time the engine's running and when it's going up and down, these things are spinning. So yeah, you can put them on either side, and that's how it's going to act when you first start it. But these things are going to move around. So honestly, it almost doesn't matter where you put them. But anyway, so those are all the rings put on. Now we're going to stab it into number one hole. I always lube up with a little bit of the Marvel Mystery Oil on the skirts, same as I do for the cylinder walls when I clean them. But you do what you do. It's fine by me. All right, got my compressor on. It's a ring compressor. Then you see that there is an arrow that needs to be pointing forward. Oh, these came with some Plasti-Gauge that I bought. I usually just use like a heater hose, whatever size fits the bolts. A lot of the newer rods, it's actually a bolt, not a pressed in stud and nut like this. But yeah, so that's what I do for that. So I like to have the deck completely flat. That way, when I put the piston in, the rod doesn't drag on either end of the cylinder wall just by gravity. All right, it's about straight. There she's in. So if I didn't mention it, the bearing is in the rod and it is pre-lubed. So what I like to do is I put the crank journal all the way at the bottom of the throw based on where it is in the cylinder. That way the rod comes down and it doesn't have any awkward contact with the journal until I get it in. And then once it's hammered in, I can push it with my hand down and I can better guide it onto the journal without any issues. And there it is. So now we just put the cap on. Like the top on the rod, we lube up our rod journal, our rod cap. So we lube up the rod cap with the same assembly lube. And then we just pop it on. The rod bolts are ARP, just like the main studs, and they assemble the same way using the molly. So I'm not torquing these now, getting them snugged down so they'll stay where they're at. We can rotate them around without any issues. And then we'll do the torque on them a little later. Now I'm going to flip it over and do the same thing for number 2. So pistons 1 and 2 are in, and now we're going to check our camshaft, which means we have to degree it in. And the first thing we're going to do is find top dead center. So I'm using the piston stop method. So we'll run our bolts down. All right, with that snugged in place, I'll move the camera around and we'll take a look at the degree wheel. So we've got our degree wheel on. I've got my pointer set up and got the piston stop on. So the piston stop does exactly that. It stops the piston before it gets to top dead center. And the reason you want to do that is because if you try to eyeball top dead center on your own, it's never, you could be off by several degrees, up to 4, which is going to make a big difference when you're trying to degree the camshaft. So imagine it this way. So this is the piston and this is the rod, and at the bottom it's connected to the crankshaft. So as it comes up in the cylinder and it gets to top dead center, the crankshaft has to throw over to the other side to pull it back down. Well, that delay in the middle, you can be off while it's transitioning from one side to the other to pull it back down. So what you do is you run it up to the stop, and I find the easiest way, you run it up to the stop and then set the degree wheel to 0. Run it the opposite direction all the way until it hits the stop again, and then find out what that number is. Whatever that number is, divide that in half. Move the degree wheel to that point, and then you can double check it by rotating through, and it should stop on that number both times. So let's give it a try and see if I know what I'm talking about. So let's move in right on the pointer. There we go. So we're going to move clockwise, and we've hit the stop. Oh, lucky, we're very close. All right. There is 0. So now what we're going to do, so we're going to go counterclockwise. Till we hit the stop again. Okay, and we're on the stop, and that is 35. So half of 35 is going to be 17 and a half. So what we're going to do is we're going to take this, loosen it up, and we're going to move it to 17 and a half. 15, 16, 17 and a half. Okay, so now if we go back the opposite direction, we should be on 17 and a half again. This is how we double check. So I'm going to go all the way back around. $10, 15, 16, 17 and a half. That is right on the money. This cam checker is from Proform, and you can put this down into your lifter bore, and you can reverse it around. It has two different sides. There. So now, with the dial indicator in place, we're going to rotate the crankshaft until we get our max lobe lift. So let's see if we can do this. So at some point, we're going to hit the top of the lobe lift. And when you hit that point, see, we hit it right there. Let's pop this around. Rotate backwards. You always want to rotate your final reading in clockwise rotation to make sure that you don't encounter any slack that the chain may have. So let's look at this again. Right there. And what we're going to do is, we're almost right on it. There we go. So now with our max lift, we've zeroed out the dial indicator. All right, so now what we're going to do is going to rotate counterclockwise. I like to use, a lot of people use 50 thousandths, and you can, and there's no problem with that. I like to use 20 thousandths just because it's going to give you, I think, a better reading because you're closer to the lobe height, but 50 thousandths is fine. I'm not saying it isn't, but I just do 20. That's just me. So we're going to rotate 50 to 60 past because we're going counterclockwise. Now we're going to come back at the reading until we get to 80. That is 80 right there. And then we're going to record our number. That number is 76 and a half. So now we're going to go forward. We're going to go past 0. And then since we're going in the direction of travel, we can go straight to 20 thousandths. Hold it there, and then we'll check that number. And that looks like it's 135 and a half. All right, so we'll do some quick math here. So you have 76.5 and you have 135.5. That is going to get you 212. Divide that by 2, 106. And that is exactly where our cam comes out. I'm kicking myself because I should have recorded this. All right, full disclosure, don't know how this happened. You can see it. See this little mark right here above and below the top piston ring land. That, I don't know, because when I got the pistons, I took them out and looked down to make sure that they were okay, but I didn't inspect them close enough, and that's kind of my own fault. So I can't blame anybody but myself. This could have been This could have been pre-packaging. This could have been me when I was handling them. Could have been at the machine shop. I don't know. So at this point, all I could do was fix the issue. Here's what the issue was. I was installing the top ring, and as I was feeding the ring around, the end of the ring was stuck right in this spot, and I couldn't get the last part of the ring on, and it was just stuck in the groove right here. And I think what happened was it got smacked right here, and I think a little bit of material pushed like a little bump up into the ring land. So I took the ring back off, and I used the back side of the ring, and I kind of rolled around the entire, because at the time I didn't see this, and I wasn't sure where it was at. So I just took the back of the ring and I put it in the land, and I just rolled it around the entire piston. And when I got to that spot, I was like, oh, there's my spot. It's sticky. So I took a little tiny, I forget where I got this file. I got it in a set maybe, but it's almost like a points file. It's really tiny, very fine. And what I did was I just went into the ring land and I sanded or filed away that little bump of material that was pinching the piston ring. I'm telling you this because it's critical whenever you're doing engine work. If something doesn't feel right, that's because it's not right. So before you move forward or just think, well, it'll probably be okay. No, don't assume that anything is going to be okay. So what you want is you want the ring to be able to float all the way around inside the piston rings land. If it doesn't, find out why and fix it. Find out what the issue is before you move on. Because the last thing you want to do is have the piston jam and score the inside of the cylinder wall while it's running and ruin all your hard work. So don't do that. If you run into an issue, no matter what it is, if you put in a couple of pistons and you're cranking it around in the next one and something doesn't feel right, if it doesn't feel right, it might not be right. It's worth checking now. There's no reason to rush. This isn't a race at this point, right? We're trying to do quality work, and we're trying to get everything put together properly. So just wanted to bring that up. I'm kicking myself because I should have recorded it while I was doing it. As soon as I realized that that piston ring was tight, I should have grabbed the camera and then showed you, and then filed it and fixed it and then showed you that. Anyway, I just wanted to bring that up. All right, let's get started. If I haven't mentioned this before, this is a good time to do so now. Never touch a bearing surface with your bare hands. You have oils, greases, acids, all kinds of junk on your fingers that you don't want on your bearings. So don't do it. Same as with the crankshaft, you have one side that's going to have that tang on it, and it matches up to the rod. Cap and rod match up to each other, and that tang on both sides prevents the bearing from spinning, which is what you do not want to do, is spin a bearing. So we've cleaned our parts as best we could. We've got everything ready to go. Get our lube onto our parts for the bearings. Now we can't forget about the wrist pin. We want to make sure that the wrist pin has some lubrication on it as well. So we're going to get right down. Let's move it over to the other side. A nice coat around that. Because we want we want some good lubrication there. Now, as I've said, I like to use Marvel Mystery Oil on the skirt of the piston. So that's what we're going to do here. So with the skirt lubed, our little protector's on, deck's flat. Let's get this down in. Tighten that down. Arrow pointed forward. Let's drive this in. All right, it seems where I have that bottom oil ring at, maybe I need my compressor in a different location. Hold on, because the spring wasn't holding those rings in as tight as I want. So before I go crazy, let me back up, make sure this is a-okay. Back down in the hole. I think I had one of the ring gaps was over on this side, and I think the way the compressor pops it in, there's like a little gap in the back, and I think it was catching like the corner. So as soon as I felt resistance, I stopped. Well, let me find out what the problem is before I go any further, you know what I mean? So let's make sure this is down nice and flat. There's actually a marking on here. It shows bottom with the arrow down toward the deck. So let's make sure we got that right. All right, let's try now. That's much better. Like I said, if something doesn't feel right, it's probably not right. So this one is in. So now I can just push it down, get it onto the journal, just like you saw in the other video, and then we'll spin it over. This was number 3, then we got to do number 4, and then we'll do on down the line. All right, I guess it's time to get going. Nice spin. Make sure everything is nice and smooth. So then we set up for number 5 cylinder. Let's get that rod right. The crank journal all the way at the bottom. Now, I'm taking a break. Nice and smooth. Smooth like butter. That is what I like. All right, well, I guess we flip it over and we'll torque all the rods down to spec. Okay, so these need to be coated with the same moly lube that you saw me use on the mains. So with the front 2 loosened up, I'm going to clean these off, Moly lube, and then we'll get to torquing. Snug them down, and then we go 50 foot-pounds. Then around to the next two. Next two. Last two. Still smooth. I've got my oil pump ready to go. This is a billet oil pump drive from Precision Oil Pumps. Honestly, not necessary, really. The stock oil pump in most situations will do just fine. So, you always remember there is this washer. It's like a lock washer that goes on there. That is, I guess traditionally you put the drive shaft down in the pump shaft, and that holds it from just dropping right out the other side of the block. Or you can put it in the oil pump itself, but it's going to fall at some point. But let's get that on. The big point is remember to put it on. There'll be some crying later. The bolts are from Oldsmobile Performance Products. ARP does not make a lot of bolt stuff for the Oldsmobiles. You can get rods and mains, head bolts, some of the, the usual stuff, but some of the more intricate stuff they just don't make. So this torques to 35 foot-pounds. All right. Now we can slip on our Mylodon windage tray. Oh, there we go. Had to get under that cotter key. Get that settled. Once I get this torqued on, I will show you some of the measurements I did on the underside to make sure that the clearances were correct. All right, let's get these guys torqued down. Mylodon says put it on with oil, torque it to spec. Since this thing is going to be in the oil pan, I went ahead and put a little red Loctite on the threads to bolt this down, just so I know when it's in there, it's not coming out. All right, let me move the camera because I'll show you a couple things I had to do to get this to work right. So here was my issue. I bought a stock style Olds 455 dipstick tube, and the end was pretty much straight, and as you can see, I've put a curve in it using a pipe bender. It was hitting right on the lip of this, and Mylodon says that this pan was, I think, like 8 3/4 from
ridge to ridge. It had to be. That was the spec for that. So that's where it was at. The problem is when the dipstick would come up, it hit right on the lip. So I notched this in it. There's going to be a notch in the oil pan that kind of goes around here. So there will be some room, but it was still hitting this. So with the curve and with that notch in it, I can get the dipstick in and it'll go in place where it's supposed to. I'm not going to drive this in until I have the heads on and I put the headers on so I know whether I need to sweep this one way or the other to make it work. But that little bit of curve in the stick and then putting that notch in will get me, because the pan sits really close to this. So I needed a little bit of a notch to get room in it. Now, let me show you something cool. So that's my phone, and this is made by Nidage, I don't know, but it is a wireless endoscope. If I turn this on, the end is even lighted. Well, I can go into my phone when I pull up the app on my phone. I can get into some pretty tight places with this. So let me show you. So I can take this guy and actually look on the inside. And what you need to do is you need to check the clearance on, hope this is coming out okay, filming me. Anyway, so as the crank turns, as the rods come up, they sweep close to the outside of our windage tray. So what Mylodon says, it needs to be a 1/8 clearance is a minimum clearance in between the windage tray and any moving part in the crankshaft. So I found a smaller screwdriver, and it was about 3/16, which is just a little bit bigger than the 1/8, and I used that as a gauge. So I would rotate the crank around, and I'd put it in like right in between the rod and where the windage tray is, and I could use that as almost like a feeler gauge to be able to get the size. Let me see if I can show you that. All right, let's see if I can show you this. So as the crank rotates and sweeps up, you can see right there. That is one of the nuts on the top of the cap, and that's as close as it gets to the pan. So if I use the screwdriver, which is 3/16 of an inch, I can get in there. I don't know if you can see this, but that passes straight through, and this is 3/16, so it's a little fatter than the 1/8 by 1/16. So I know that this is within spec. Mylodon says that it has to have 1/8 clearance between any moving part of the crank and your windage tray. And if you don't have that, it voids the warranty. So I had to check all the way through for the connecting rods that actually hit the front two, don't sweep through it, and it's just these back ones here. So I checked them all to make sure everything is clearanced out. Good to go. This is a fuel pump block-off plate. I got this from Rocket Racing and Performance. I could have made this. It's just a block of aluminum. I could have cut the size out to fit the gasket, drill the holes, but I like that. That's cool. But like with everything else that I do, it's got to be custom, right? A couple of coats of Oldsmobile Blue. This thing will be ready to go. There we go. A couple coats of paint. Custom. Looks pretty cool, huh? Almost. Not quite. Let's get a little of Eastwood pre-painting prep. Soak that down. Let's give this a couple of wipes. You can see that. Now it's cool. I like that. I like that. So I oiled the chain again before I put the cover on just to make sure it's good and soaked. So we're going to use a little Eastwood pre-painting prep and just clean up our gasket surface. Make sure everything goes on as clean. Yeah, that's what you get from just sitting around in the garage for a while. It was clean. Oh, it'll be clean again. Now, if you can notice it, at the top around the coolant passages for the water pump, it is slightly corroded. Slightly is probably an understatement, but yeah, so I'm gonna see if I can't get something on that. There. Get something on that because it's pitted. And I don't know if that was from a leak that had been going for a long time, but it had corroded right around. This one isn't as bad as this side. This one's almost the whole way around. So what I'm worried about is when the gasket goes on, there could be some small little channel that the gasket is not covering that could precipitate a leak on the outside. So I just want to make sure that this area is sealed off so it's not an issue. So I think what I'm going to do is use a little silicone on that. So here's how I think I handle that. I'm going to take a little dab of silicone and I'm going to go around. And this is just a tiniest bit. What I'm trying to do is just fill in where the corrosion pits are. Nothing extravagant. I don't want anything, I don't want it like just blobbed on there because it's all just gonna come back out. I just literally want to film. I want enough to fill in those crevices so I know that when the gasket goes down, it's just sealing against a flat surface and there's no chance of coolant coming out. There we go. I think that ought to do it. It's like Brill cream. It's before my time, but the advertisement was just a dab will do you. And that's all you need here. I just need enough to kind of fill in those spots so I know that when the gasket goes on, it's going to have a nice clean surface to be able to mate to. In fact, the corrosion was so bad, the front cover, I had to buy another front cover. I tried cleaning up the one that I had and it was just really rough. And I was just looking at all the corrosion in the water pump area and I was just wondering whether that was going to be able to seal once I put it together if I used it. And I just decided to cut my losses on that and bit the bullet and got a new front cover. Glad I did because especially with all the front pulleys and everything that goes on this, and then this is leaking from the gasket out here and it's leaking coolant. That's a pain to have to strip the whole front down.
balancer's got to come off. Now you've interrupted the seal in the oil pan. It's just, nobody wants that. So, yeah, so this will do. Make sure there's none in the passages. All right, I'm actually going to let that set up just a little bit. Let it get just a little bit past where it is. I want it to solidify just a tiny bit, so we're not squeezing that. We're actually pressing on it like it's part of the surface. That way, when we put the gasket on, we don't have to worry about it. I feel better that way. Okay, after a couple minutes to let it set up, get taggy. Let's go ahead and pop that in place. Make sure all my bolt holes are lined up correctly. All right. Make sure I got good contact with that silicone. Excellent. Okay, now we can get the front cover. All right, so like I said, I bought a brand new cover just because the one that was on there was so corroded. All right, I'll be close enough to get our bolts in. So when it comes to engine bolt kits, there's not a lot of options out there, but one of them is pretty cool. It's a place called Alloy Bolts, and I bought their hex head stainless steel 455 engine kit, and it comes everything individually packaged. As you can see, this is water pump, and everything is the nuts, the bolts, the washers, the lock washers, everything comes individually sealed, so there's no doubt where everything goes. So I'm just going to cut this one open. All we're doing is the bottom 4 bolts. Water pump isn't going on just yet. So let me crack that open. So 2 things to remember when using stainless steel bolts. You have to use an anti-seize on the threads or you'll gall the threads and good luck getting the thing back out. It becomes a mess and you don't want that. The second thing you need to remember, as soon as you crack the lid on this, if you are not careful, you will look like the Tin Man from The Wizard of Oz. This stuff gets everywhere. I don't know how it does it, but it goes everywhere. You can crack the lid on this and there's some on the back of your neck. How? But you need to be careful. I'm telling you, this goes everywhere if you're not careful. So let's get the bolts on. So the manual calls for 35 foot-pounds. I did wire wheel a couple of the original bolts, and that's just because I'm not ready to put the water pump on just yet. But I want to have the top part of this cover snug down to the front of the block, just because of that silicone that I put in there. I just want that to kind of take a seat. Just snug, have it in place. There. Those will go off when the water pump goes on. But for now, I just want the front cover to be flat. I don't want to catch the top and end up like yoking it or doing something stupid. So this just holds the thing in place. Plus it gives a good seat for that silicone that I put around the inside of that, just so it doesn't go funky on me or anything. Well, let's get it flipped upside down, and I guess we'll put on the oil pan. Same deal. First, we make sure everything is super clean before we go any further. All right, we'll start with the front cover seal. See that little center nipple? That corresponds to a hole that's right here in the front, so you can't really get it off kilter. So what I like to do is get a little bit of sealer down in the corners here. And then I will put some along this front ridge. That's good. This guy goes in tight. Kind of push one side in and then roll the other. And it's quite a snug fit. There we go. And then squeeze it down from the center out. Get our ends in place. Back is the same thing. This outside edge, I like to put a bead in there, just up on that one corner. Help aid in sealing it. All right. And then the back one goes on a little easier. And there is, you can see that square channel. There's a channel down here that plugs into. I'll put a little right here on the mating surface, right on the bottom of the block where the seal meets. There we go. I like to start on one side and get that seated down in, and kind of roll this side around and do the same thing. There we go. And then the same thing, a little bit of sealer on the top, right where the gasket's going to meet that. All right, let's go get our gasket. So if you see on the pan gasket, you can see this little tab. That fits into the rear, and there's like a little notch in the rubber seal where that fits. On the front, you've got this notch right here. That notch is where the front cover goes. So this goes in between the front cover right at the corner. So when this goes down, that notch is right in there. And since I got the nice high tack on it, I can just stick this down and it'll stay. And we come around to the back, and then that just pushes right into that little notch. And then we'll just take a little dab of silicone to make sure that that seals in. Same at the back corner, on all four sides. All right, ready for the pan. All right, let's get this down nice and easy so we don't disturb the gasket. All right, now we'll start tucking our bolts on. Oh, sorry about that. I had to hustle. I put everything down and I forgot, of course, anti-seize on all of these. So I had to hustle to get the anti-seize on real quick and get everything in. Probably made a little bit of a mess. Just trying to make sure that I got the thing in and down before my silicone started setting up on me. Now, if you've heard me say, when it comes to cork gaskets, I don't pay attention to any torque settings because these things are notorious for not wanting to go down right, or they're notorious for splitting, shall I say. That's a better way to put it. That little guy. I'm gonna have to check that one. I'm gonna have to run a tap through it. Looks like it does not want to. It threads halfway down and stops. I don't know. So I didn't chase any of these when I put them in. So that's my own fault. Let's try it again. Yeah, it gets... I might have to come back to that one and chase the threads in the block just a little bit because it doesn't want to... Gets halfway down and stops. I have to check the threads on that. Anyway, like I was saying, I had to go around and hustle to get the anti-seize on the bolts before they went in, so whoops. You do this for so long, you can almost feel, oh, it's hard to say, but you get a feel for right where that line is at, between tight and too tight. When it comes to cork gaskets, you kind of end up dancing that line all the time. All right. Like I said, except for that one bolt, I'll have to find out what's going on with that. All right, curiosity has got the best of me on this. Let's take this little bad boy and see what's going on. So I put the anti-seize on, so I know it didn't gall the threads. But I can send a tap down through that one. Let's see if it helps any. I don't see any sign of any issues with the threads on this. All right. Yeah, let's give that a try. Okay, let's see what's going on here. So I've got a tap. The hole is blind, which means it doesn't go in anything. It just dead ends to the bottom. It's not open into anything else on the other side. So I'm just going to drill it out. Not drill it out. I'm going to run the tap through it. See if there's maybe not like one damaged thread somewhere down in the bottom of that's causing the problem. Because the bolt runs okay about halfway down and then it gets jammed. And I could probably force it, but then you got to think about later on. What if this pan has to come off? What if it leaks? What if, God forbid, something goes wrong inside and the pan has to come back off? There's nothing worse than laying on your back underneath the car and fighting one bolt that you cross-threaded into the hole. The bolt size is 1/4 20, and I've got a 7/32 socket, which actually fits this perfectly. So I am just going to roll this thing down in here.
See if I can feel what it is. It's got anti-seize in there, so I'm going to use that as its own lubricant. Let's see if I can find where the problem is. Nothing yet? Oh, maybe that's it. Yeah. Okay. We're just going to work. It feels, yeah, feels like there's a couple of threads like right at the bottom of the travel that are just not being nice. So we're just gonna run back and forth. See if we can't get a little compliance. That seems to be a spot right there. Okay. Let's see how deep that was. I might have did it. Let's find out. Yeah. Got a little bit of trash. Where's that? A little bit of trash right there on the end. Some of that's the anti-seize, but there's a little bit of junk in that. All right. So what I'm going to do is get some brake clean or something, just to spray a little something in there and then blow it out, get any debris out of there. All right, let's see what we can get, just a little bit. All right. And we'll cover this up and see what comes out. Messing up my pretty pan. All right. Now, anti-seize. Anti-seize. All right. Well, if you're going to build something, that's better. Yeah. If you've never worked on your car, or you have, for that matter, then you'll know. Everybody's like, yeah, you hear a bunch of people, oh yeah, replace that thing on my thing with the other thing, and I just did this, that, and it was perfect, and it went together. That never happens. I'm going to tell you right now, you're always going to run into some type of problem. This is kind of one I made for myself because I should have really just run a tap down through some of these holes just to make sure that everything was good once I got it back from the shop. And I didn't do that, so that's on me. But problems when it comes to building things is not the exception, it's the norm. All right, I'm rambling. So the point I'm just trying to make is, if you're going to do something like this, or you're thinking about doing something like this, and you get your feet wet, expect for there to be problems. Just expect it. That way when it happens, you're not surprised. Figure it out, and you fix it, and you move on. That is what separates the men from the boys, I guess. Anyway, that is the pan. Almost forgot our fuel pump block-off plate. Don't want to forget that. Let's see. Let's get that on. We'll get our washer and nut on here first. There we go.
All right, this bad boy takes 25 foot-pounds. That's kind of cool. I think what I'm going to do, like on these pins here on the front of the timing cover, end of this little stud here, try to get a little touch-up paint on those just to have them painted so they don't rust or go bad. So now it's cylinder heads. Before I can get the cylinder head on, I need to make sure that we have a nice clean mating surface. So I don't want to get any residual oil that may have gathered on this off. All right, first things first. I'm using Cometic gaskets. They say you can put them on dry, don't need any type of sealant or anything. I don't know. I always feel like, at least around these water jackets, and we're not talking much, but around the water jackets, I like to put just a little bit, just to make sure. We're talking very little. Just enough that I feel like they're going to seal up on me. Again, you ask Cometic, and they say don't do what I'm doing. So, don't do what I'm doing. But I'm certainly going to do it. So a lot of people, this is Cometic gasket by the way, it's multi-shimmed gasket with like a silicone based type outer layer on both sides. So there's a lot of talk. People will say, well, the Cometic gaskets are reusable. Yes and no. If I bolt the head onto this and torque it down the spec, and I never run the engine, and it never heat cycles, I can reuse this gasket. But once it heat cycles a bunch of times, see these things, the steel in them, the way they're made, the several layers, they're sprung almost. They're like twisted a little bit. It's adds some of the tension to it. Well, once you go through a couple of heat cycles, that tension kind of goes away, and you can't reuse the gasket then. So, something to know. All right, we'll get one bolt in here started, just so our head doesn't go flying off and hitting the ground. Edelbrock RPM aluminum cylinder heads. I like those things. ARP chromoly head bolts. Now you're wondering, why do you paint it silver? Well, if you'll notice, all the other hardware on the car is this stainless steel, goes on the engine. But the head bolts, ARP sells stainless hex head bolts. The chromoly ones are $85 for a set. The stainless are $155. So I found, like right here, okay, you can tell they're not exactly the same. But I found this high heat exhaust manifold paint, and I painted the end of the head bolts, and I baked them to get the finish to kind of be a little bit more secure. So from close up, but from here, I don't know. Looks close enough to me. So the ones up here that are going inside the head, no need to paint those. But I did paint the ones that are out here on the outside just to kind of follow that same theme because I'm cheap.
So anyway, I have to take all of these. If you remember the same lubricant that ARP has you put on the main and rod bolts, everything. Same thing for this. So I've got to lube everything up and then torque them in series until I hit 70 foot-pounds. So let me get it's going to take a minute. So I'm going to get all this stuff lubed up and then we'll drop it in and torque it in place. Oh yeah, almost forgot. See that bevel on the washer? Other side is flat. Bevel. Bevel side has to be toward the head of the bolt. So it leaves a little room for the shank end at the just the very end of the head of the bolt. If you put them in the wrong way, the bolt can break. Definitely going to void the warranty, and ARP is not going to stand behind it. So make sure you get that right. So if you didn't have the proper torque sequence for tightening a head down, a good rule of thumb, this is if you don't have anything. Good rule of thumb is if you go in an outward circle, you're going to be right in the ballpark. So if we didn't have anything, I would start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then do that two more times until I got to my final torque reading, and it'd be good to go. Oldsmobile in the book, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's how we're going to torque this down. And it's 70 foot-pounds is what is recommended from ARP, and we're going to do that in 3 stages. I'm going to start with 30 and work my way around. Now, I read this on a forum, and I'm curious to see if it works. They said for painted bolts, when you go to torque them down or tighten them, if you want to try to eliminate chipping, take a sandwich bag and put over top of your bolt, and it gives it just a little bit of a cushion, and you don't mess up the paint. Huh? Maybe. We'll see. We'll see once it's done and I clean everything off whether this is actually going to work. So that was 30. Now we'll go to 50. And then final torque is 70. All right. This is going to get a little bit tougher here. Final torque, 70. See if we can handle that. Last one. All right, well that's both heads on. I don't know if the plastic's anything or not, to tell you the truth. There is a little bit of flaking on a couple of them. From right there, you can't see. I think it looks good. There's a couple of spots though, but I don't know. Would it have been worse without the plastic? I don't know, honestly. Anyway, let's roll this thing around and I'm going to talk about rocker arm geometry and pushrod length. First thing I need to do is I need to get the camshaft down onto the base circle, or what some call the heel of the cam. So if
you're familiar at all with it, you've got the cam, which looks something like that, right? So this is your lift, and this is the base circle of the cam. We need to get the lobe on the base circle side so we're not dealing with any lift at all. So I'm just going to use the number 1 cylinder. I'm going to turn this thing around until I can get myself to the base circle of the cam. There, that is good. This is a hydraulic roller. So on the end, you have these roller balls. So in order to keep these from turning sideways, which then they wouldn't roll, they would just dig right into the cam, they've got to be held in a certain position, and that's what this bar is for. So we're going to throw these right down into the lifter bores. All right. So this is what is this from? This is from Comp Cams, number 7902, and it is a push rod length checker. These come with 2 nuts on the end that aren't big enough to get past the plate at the top here. So I just took them completely off, and the threads are actually stiff enough that I don't think I'm going to have an issue with this thing. So, oops. How about I put it on the right cylinder here? The right lifter. Okay. So that is in the lifter. Let me get this turned around and I'll show you the rocker arm part of it. So this is our rocker arm. So you've got the trunnion and you've got the small roller at the end. And the trunnion, there's only one way for this to go on. You can see this is the bottom side. This is the top side because it actually has, see that? Has a place for your nut to go into to have a flat surface. So it only goes on one way. What you're trying to do, you draw a center line in between your trunnion and the small roller, and that's your center line for where you want the rocker to sit. So what you're looking for, so we screw this down. Get that in there. All right. So you want 90 degrees to your valve. All right, so if that is your valve head, so we want to loosen this up a little bit until we have this right at the same angle as that. That's about right. Okay, so this is our starting point as far as the nut. Now, what we need is for this rocker to be that same 90 degrees to the valve stem head when it's at half of the lift of the cam. All right, because this is rolling slightly forward and backward. This is exaggerated, but this is what it's doing as it's rolling, as it's compressing the spring and the spring is coming back up. This is rolling just slightly forward and slightly backward across the center of that valve tip. So halfway down, which is about half of your lift, you want that to be at 90 degrees. So it's optimal for both directions. So I have to move the camera again. Anyway, so now that we have this is our baseline. This is where we're going to start.
all the adjustments will come from this point, because now we've established 90 degrees, not accounting for lift. So now what we're going to do is we're going to actually tighten this down until we have half of what our lift is. And I'll explain that in just a sec. All right, so now we've established our baseline. Let me throw this right on here. That way we can keep track of the number of turns. All right. That is the top. All right, so here's the basic gist of it. So with it adjusted right where it's at, this is going to be at a nice 90-degree angle. What happens is, as you tighten this down, it moves this down, and then your angle goes upwards. But what happens is, when the cam gets halfway through its lift, the front of this is going to come down, compress the spring, and you'll be back to your 90 degrees. We just need to get there. Here's how we do that. The camshaft on this engine is 555, 560. So, you know, like I've always said, what's 5 thousandths between friends? So we're going to go with the 560 lift mark, and half of that is going to be 280 thousandths. So the stud that's holding this on is 7/16, and it's 20 threads per inch, which ends up being 50 thousandths for one full rotation. So we know that we're going 280, so we're just going to turn. So that's 50, 100, 150, 200, 250, 275, half of 50, 25, and then right about there, we'll call that our 280 mark. So with the rocker like that, we're going to take our push rod, push that up to hold it in, and then we're going to do our adjustment down here. And all I'm doing is unthreading the push rod until it meets the lifter in the bore. And then what we're looking for is for zero lash, or just basically it's very tight. There's hardly any movement. All right. Okay, so now we've got a correct rocker geometry. I've got zero lash on my push rod, so now I can loosen this up. And then if I'm careful, just pull this out. There we go. Measure that, and that is our push rod length. So that measurement comes out to 9.157, which is perfect. Most push rod manufacturers make their push rods every 50 thousandths. So 9.150 is what we're going to end up with. All right, first things first, we'll get my homemade Valley baffle tray, whatever you want to call it. Put a little red Loctite on the bolts. Really couldn't find a torque spec for this because they're just little tiny, they're 1/4-20 bolts. So a little red Loctite. I want to keep them where they're at. I'm just going to snug them down by feel, what I think is good. There we go. I found online for a bolt this size, I think the torque spec was like 5 foot-pounds or something crazy, and I don't have anything to go that low, so it's red Loctite and snug. That ought to work. Here are the Morel roller lifters, and you've seen them before. I figured I would show them. Look at the case they came in. You know, as much as you have to spend to get these, and they should come packed nice. Anyway, I'm going to get these out and clean them. Quick tip. It said in the instructions that there is some type of grease that they pre-lube the roller balls in. So those rollers have little bearings in them, and those are pre-lubed at the factory. Do not submerge your brand new roller lifters all the way in cleaner, because it'll wash that stuff away and it just causes premature wear. So you clean the outside of them, that's it, and you put them in. All right, with it cleaned off, what I'm going to do is put a little bit of assembly lube on this. Make sure they go down in the bores nice and slick. Make sure the roller's got a little on there too. The bars go out. So when they go in their respective holes, bars on the outside. All right, just 7 more to go. Next come the push rods. So we'll just do it right here. Get some assembly lube right on the tips of the balls there. And I'll just throw these in. Spider webs. Next are the rockers. What I like to do for them is just so, because they're going to sit for a little bit, I like putting a little, I just take a little lightweight oil and I put it around that trunnion and then some back here on the roller ball. Just enough to keep it lubed. The bearings in there. All right, so let me talk real quick about adjusting valves. As I used to do it very different than how I do it now. So I was very much in the camp, lifters go into some type of container, bucket oil, whatever you want to call it, and then I'd let them soak overnight. Let them soak overnight, fill up. Next day I would come in, then I would be ready to install the lifters, push rods, rocker arms, and then I would start my adjustment procedure. Hydraulic
whether it's flat tappet or roller, you can adjust them without having to run the engine. You can run the engine and do it, which is basically while the engine is running, you're making a mess everywhere, or you got some piece of cardboard in here trying to hold back the oil and everything else, and you're loosening one valve at a time. And you loosen until it starts to clack, and then you turn it back down, and that's where you would kind of get your adjustment from. Hydraulic valves, you don't need to do that. You can do this cold on the engine. In fact, I looked on Morel's website, and their recommendation is once you get them to zero lash, and I'll explain that in a minute. Once you get it to zero lash, then it's for cast iron block with aluminum heads, it was 35 thousandths preload, which means once you get it to, so let's do it out here. So this push rod, I can spin it and I can move it up and down. So we're basically tightening down our rocker arm until I can still turn the valve, but all of the play is gone. And I can feel that there's engagement on both sides. I mean, it turns, but it's got just the tiniest bit of drag on it, all right? That is at zero lash. Then what you do is from here, you would turn the nut back down 35 thousandths, and that would preload the spring and cup that's inside of your hydraulic lifter. 35 thousandths just happens to be just under 3/4 of a turn. So each one of these, I'm going to give them 3/4 turn, and then we'll be good to go. But so let me loosen this back up so I can explain. All right. Before, I would do it like most everybody does, which is still acceptable, still a perfectly good way to do it. It's basically doing the exact same thing as I'm going to do it when I show you now, which was to turn your number one cylinder to top dead center, which means both lobes are going to be on the base circle of the cam, both valves are going to be shut, and the piston is coming up to the top of the stroke. So with that done, I can sit and I can adjust these two to zero lash, put in my 35 thousandths turn, lock them down, and then I could rotate it 90 degrees and go through the entire firing order, 1-8-4-3-6-5-7-2, or in my case, it's 1-8-7-3-6-5-4-2, because it's a 4/7 swap. So that is how I did it forever and a day. And it works, and it works. Then in 2016 was when he made the video. I can't remember when I saw it. There's a video from Ellison's machine shop. And he said that he'd been building engines since he was basically, I don't know, 17, 19 years old. He's been working in a machine shop. And he apprenticed and did all his work, got good, opened his own shop. And that's what he's been doing for 40 years, I don't know. So he said for the longest time, he was a one-man show. So when he got into the shop to adjust valves, he was doing it that traditional way. Turn it till you get this up on top dead center. Both valves are closed. Lobes are on the base circle. Adjust 90 degrees, and go. You adjust 8, and then you just go through your firing order, and then you're done. What he said was happening with him was, and I'm going to put a link for the video that I'm talking about down in the description. It's got like 1.3 million views, so you might have already seen it. So he said what he would do is he would be in the middle of adjusting valves, and he'd have to take a phone call, go talk to a customer at the front desk, be pulled off for whatever reason, and then he would come back, and he's like, daggone it, I can't remember where I was. What cylinder have I done? What have I not done? So he devised a very simplistic way. As soon as I saw the video, it was like someone smacked me in the back of the head. I was just like, well, yeah, it makes perfect sense. I don't understand why. So what he does is he starts, and it doesn't matter where he starts. He just starts at a clocked point on the crank, and he takes all of the lifters and adjusts the rockers until he's at zero lash.
So he adjusts everything to 0 lash. Now, you would think that doesn't make sense because some of them are up on the lift. How you can't adjust it that way. But what he does is he adjusts all of them until they're all at 0 lash, right? None of this movement, none of this play. Gets them all to 0 lash, 90 degrees. And then from that point on, all you're doing is going around any rocker arm like is loose and is not at 0 lash. He tightens that one until there's no more play and he's at 0 lash. And then he goes another 90 degrees and he checks all the loose ones again. Any loose ones goes to goes to the 0 mark. I mean, it's you're doing the same thing, but you're not having to keep track of where you're at because it's only going to be loose as it comes down. Like if you happen to catch it right at the very top of the lift and you tighten this down to 0 lash, and then you rotate it 90 degrees. Well, now the camshaft's coming back off the other side of the cam lobe and the lifter's going back down. So it's loosening back up. At some point, it's going to be on the base circle during that 90 degree check, and it's going to be loose and you're going to adjust it to 0 lash. And then when you go back another 90 degrees, that one's never loose again because now it's not, you caught it on the base circle and you've gotten it to 0 lash. And now it's pushing the plunger down because it's back up on the lobe. But it never gets loose again. It's going to always be at your 0 lash. So the way he does it, he does not lube the lifters. He doesn't put them in anything. He puts them in dry. I mean, you lube the outside of it so it goes down the bore. But he puts them in dry, so that way you're not fighting this hard lifter that's full of oil. You're fighting just the spring, and the spring it's fine. It's I don't know why I like when he said it, it just like it went off in my head. I was like, I can't. That makes perfect sense. So then you go through 2 full rotations of the crankshaft, 90 degrees at a time. 90 check, 90 check, 90 check, 90 check, and then do that again for a whole rotation. You can even go more than that if you're paranoid or anal retentive like I am, and I probably will. You just keep going. You can do an extra 2 90s if you want to, and just make sure everything is at 0 lash. Once you have everything 0 lashed, then you just tighten every single one at the same time. You're 3/4 turn down. They're all preloaded and all ready to go. Put the valve covers on and fire it up when it's ready to go. I saw that and I was just like, daggone, that's so obvious and so simple. I'm amazed that I went that long in my life and never heard of it. But there it is. And that's exactly what I'm going to do. So I'm going to grab a wrench for these, and I'm just going to, in fact, probably most of them I can do finger tight, and it'll be where it needs to be. But I'm just going to go and rotate every 90, and then just check for tightness. Get everything at 0 lash, and just keep doing that until there's no more loose push rods, and you're ready to go. It's so simple. All right, so now I'm going to take it 90 degrees. And that's it. And we'll check them again. Yeah, there's a loose one. Yeah. This is ingenious. It's so simple. Another 90. One more, just for good luck. That's pretty much it. I have hit all of the cam lobes on the base circle for every valve. So now we've got 0 lash on everything. So now all I got to do, 3/4 of a turn, and tighten them down. That's it. I put the valve covers on, start this bad boy up. Feel pretty confident there. Everything's going to run fine. This is so much easier, I think, especially if you're in a situation where you're going to have to walk away and come back. Nothing wrong with the old way. Nothing wrong with the way. Starting with number 1 cylinder, put it on the heel, adjust the 2, 1, 8, 4, 3, 6, 5, 7, 2, just like I said. You can adjust them that way. It's going to be the same thing. If you've got the time, why not? Doesn't matter. But man, this was so easy. And didn't require any real thinking. I just had to remember to turn it 90 degrees after I checked all 16 and go to the next. I like it. I really do. So if you've never seen these before, these are called poly locks. So like a normal nut that you would see on a rocker arm, they're splined to the top to where they provide some resistance, so when you tighten them down, that's all you do is you tighten them in place and you're done. These will just, they move freely. So they have a center adjuster that you tighten down, and it puts pressure against the top of the rocker arm stud, and that's what holds it in place. So we go around, we've got to do almost 3/4 of the turn, and then what I do, tighten my poly all the way down, and then done. Tightened in place. So let me just do the rest of them, and then we'll be ready to go. All right, with all of them adjusted up, let's give it a little turn around. Beautiful. Even comes with header bolts. Let's get this center one kind of up in place here. Get in there, you.
So as I was saying, this was a group buy. So I don't know if that means we got a decent price. 550 seems steep to me, and so I started looking at their header sets they had online, and I'm like, oh well, maybe that was an okay price, because Cook's headers are not cheap. They are not, but they are. Can't even get my chubby fingers in there. There we go. They are very nice. That's good enough for government work. All right. So the headers are 2-inch primaries leading down to a 3.5-inch collector. Now, it may be just a touch on the big side, but it is 468 cubic inches, and there is, with these heads, a potential of making 520 horsepower and probably somewhere close to 600 foot-pounds of torque. So maybe they're not so big after all. I don't know, but they're what I got. So now what I have to do is figure out the best placement for my dipstick tube. So let me swivel this thing around so you can see. All right, here is what we're talking about. Right down in there. That is dipstick hole. So that bad boy is right down in there. And well, I think that's going to be it right there. All right, so let me show you how we get that thing in. So the dipstick, you can see these different bulges right here. Those are to basically pinch against the hole and it holds it in place. So what I do is I get a little black RTV and I get it smeared on that. I'm going to smooth that out a little bit, and then that will be in between the crevices for those two. So when I drive it in, that will just give it a little extra something to help seal it. All right, I'm going to be honest with you. I don't know how well this dipstick is going to read anymore. And actually, see if I can get this up here. I had to lop off the very end of the dipstick. Just, you know, like I said, these are the aftermarket things you have to deal with, right? Because I had to bend the tube a little bit to be able to clear the windage tray, which put it off from where it's supposed to be in the pan. It's a thing. You know, it may not read accurate, but it looks good. And it's where it's supposed to be. I sealed up that hole down there. So anyway, let me swing this around because I think I'm going to get the oil filter housing on. All right, got my stainless bolts with my anti-seize on them. Let's get this one started. These all go down to 35 foot-pounds. So if you're an Olds guy, you know the 51-258 Wix filter. It's the standard, it's the go-to, it's what we all use, or the Napa Gold or Platinum, because I think Wix makes those as well. But do you know the 51-522 XP? So Wix makes a race filter, they make the XP, and then they make your regular everyday Wix filter. So the regular everyday Wix filter, I think it filters like 20 microns, and then the race filter filters less than that. It's like 35 or something. This is in the middle. So it doesn't filter as much as the standard filter, and it filters a little bit more than the race one. The race one, it doesn't filter as much because they're looking for the maximum amount of oil flow that you can get. But for everyday street driving, you want the engine filter on your car. You want that oil filter to filter as much junk as it can, right? So I'm going to start this thing up, and I'm going to break it in using a break-in oil. And what this does is it helps not filter out as much of the additives that go into that oil to help break in the engine. So if you went on to the Wix website and looked at Olds 455, you would not find that this filter fits. But if you go and look at the Olds 307, like 87, which is what this car is, you can find this filter number. This housing and the housing for the 307 Olds that I have, I held them up side by side, and they were exactly the same. The fitting on the bottom the same, thread the same amount of perch area for the filter. It's all the same. So when I break this engine in, I'm using the XP as my filter. And then once the engine is broke in, the favorite, what everyone uses. So I finally found a use for those 87 valve covers with not enough bolt holes. This is perfect. Anyway, we're gonna pop these bad boys on, and hopefully this helps to control the oil that's going to try to run out of my engine that I don't want to. So the last thing you want to do is spend all this money on an engine and then not use proper oil to break it in. So that's why I'm using the Driven oil. I think this is a Joe Gibbs owned company. I'm not sponsored by them. It's just after doing some research, it seemed like the best thing to use. This is BR30. It's a 5W30, which I think is going to work well for me in my application. And like I said, not sponsored. I'd like to be sponsored. Gibbs, you out there? Give me a call. My phone is ready for you. All right, so what we're going to do is we're going to put in 5 quarts. Make sure the oil pan drain plug doesn't leak, which would be my luck. And then I'm going to check the dipstick, because I've been a little worried that that dipstick is not going to read. So anyway, let's start on this side and bathe the lifters as this stuff goes in. Four more.
There's 5 quarts. It is, without a doubt, cold. We're going through a cold snap. So oil went out pretty good. I've had the heater on for a little bit in here, but it's still cold. So I'm going to let this sit for a little bit and drain down to the pan. Once all 5 quarts are relatively down in the pan, what I want to do is check the dipstick and see if I actually have a reading. I'm kind of wondering whether the dipstick's ever going to read it, because I had to like bend, if you remember, I had to bend the tube around just to get the thing to work. So let's see what happens. All right, I think most of that 5 quarts is in the pan, so let's see what we got as far as, okay, well, I've actually got oil on the dipstick, which is good. So let's put this bad boy back in and see what we got. Okay, so this dipstick, I don't know if you can see that or not. Bring that up there. I don't know if you can see. Anyway, I'm not sure if I can make that clear enough for you or not, but it's, the level on it is way past the full mark. But that doesn't matter, because what I'm gonna do is I'm gonna remark it. So let me grab something here. All right, I'm gonna see if I can take my scribe. I'm just gonna put a line across this real quick. Just enough to highlight where it's at when I wipe the oil off. Then I'm going to try to run a file across that and create a little line. Grab the file and I just ran a line across that. There. So that is going to be lowest point as far as oil fill. So that's going to be add oil. That's going to be my spot. And the reason I figured that as the add oil spot is that I haven't primed the engine. So you're talking, there's 5 quarts in here. If I had 6 quarts in and the thing was primed, oil filter would be full and there would be oil through all the passages, and more than likely this would show, I think, closer to what 6 quarts would be primed. So that's going to be my add, and then now I'm going to put the other 2 quarts in. I'm going to prime the engine and then let it sit for a little bit, and then whatever shows up is going to be my second mark, which will be full. So yeah. All right, let me put this back in. Keep it safe and out of the way. And then we will, this thing is tricky, and then we'll get to priming this thing. All right, so let's go ahead and get this done. This is an oil primer that actually fits on an F-word engine, 351 Windsor to 460. The puck doesn't quite sit down in the distributor hole the way it should, but it is close enough for what we're doing, and it does fit the shaft, and that is the most important part. I tell you what, it's almost, but it just won't. There must be something that can be done. Let me see. Never throw away a bolt or screw or fitting or sensor or O-ring. Maybe I keep too much, but I always, every toolbox I've had when I worked in the field and at home, I always have a junk drawer that every loose screw, bolt, or whatever, I just toss it in. So I don't even categorize it or anything. It's just in here. So it's probably a horrible system because I end up just rooting through trying to find what I'm looking for, and I should probably categorize this stuff, but I don't, and there it is. So I'm going to find something that can't fit that puck. Got it. All right, so what are we doing? All right, let's stick that in there like that. All right, let's see. I found some
random nut that should fit this side. It's not gonna. All right. All right. Let's see if we can't do a little file and fit. Yeah, that's better. Let's see how she fits after a couple of test fits. Ha! Like a glove. All right, so you also have to remember oil pump shaft on Oldsmobile counterclockwise. That's how it spins. And I'm going to start off slow because I want to make sure that my pressure gauge doesn't leak, because I've never used one of those manual gauges before. I've always had electric. So I'm going to start off a little slow here. Yeah, I'm hearing the oil filter cycle with oil. There we go. I'm starting to get a little bit of back pressure here. Yeah, I can hear it. All right, I'll let that sit for a little bit. I'm starting to see some oil coming up. I'm hoping these valve covers are tall enough. Yeah, I got a little bit here and there. Like I said, I hope these valve covers are tall enough that when the oil runs over, it doesn't run out. All right, let's keep going. All right, we're getting good flow. Now, here's something that I think some people may get confused on when you're priming an engine. You look at it and you're like, oh, got oil, 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 oil. Everything's good, everything's good. Oh, wait, this one here doesn't have any oil in it. What's going on? How come that doesn't have any oil in it? Daggone it, I got a bad lifter. It's not always the case. So what happens sometimes is the oil feed hole that is down in the lifter bore, sometimes you can have the lifter just positioned the very right spot where it's not quite getting oil transfer. So sometimes when you're priming the engine like this, what you do is you prime and prime until you start seeing oil on the top end. Once you start seeing oil coming out, if you identify like one that's not getting oil up through the push rod, don't freak out. Take the engine, rotate it like 90 degrees, prime it some more. If you don't see anything, rotate it another 90, prime it some more. Once you go through a 180, if you don't see oil then, okay, well, if it's not getting oil, you got to investigate what it is. But let the cam cycle through one full rotation off the lobe and back just to put that lifter in a different position. A lot of times what it'll do is it'll fix your problem without you having to freak out or think there's something wrong. So I must be sitting in a good spot or doing something right, because I have got oil flowing in every single one. And I've got when I put this thing together, I took a drill and I opened up the drain holes on it wider, because Oldsmobiles have a heck of a time when it comes to oil drain back issues. So trying to avoid any issues. Looks like it's running down through that trough at the bottom and into the drain hole of the head. That looks fine. I'm going to run it a little bit more here. Let's see, now that this thing is jumping with oil in it, it makes it a little hard to hold it, but let's see if I can't position this down. So we're getting about, I would say about 90 PSI, which I think for this is perfect. Let me get it somewhere where there's no glare on it. How about that? There we go. Well, I think actually while I got it, I'm going to rotate through all 4 cycles and just let this thing move and chug. Make sure that we don't have any spots on the lifters where it's not lined up with the oil hole, just to make sure. I mean, it looks like from what I see, I got oil everywhere. I'm good, but I'm just going to go ahead and do this spot anyway. So let's see if I can hold the torque of this thing and do this at the same time. I don't know if you saw it. I just, for the spark plug holes, I just a piece of heater hose that I just jammed some tape into to plug it up. And I had them just, also I used them when I was painting. And while I was cranking it over, you saw those things going boop. It's popping out the side. It's funny. That's 7 quarts, primed, top end, flowed down, let it sit for a little bit. Some of the oil can run back to the pan. I think we're in good shape now. So now let's check and see where our oil level is. All right. Oh, that's not bad. It's right, if you can see that or not. Don't know if you can see that, but it is right at that U in use oil. So I am going to put my second scribe mark right at the U, and that will show me full. So there are my 2 marks. Got my full, and I've got add, and I've even got some bootleg looking crosshatch in between. So that is full and fill. Quick check of the front seal. Well, that looks good. Drain plug is dry. And let's see, we can't get, back of the engine is dry. Okay, here's where we go into full disclosure. So when I prime the engine, there's actually a little bit of time in between when I did the prime and right now. Because when I was done, I saw a trickle of oil all the way down and underneath the pan. And I was just frustrated. I just knew it was a rear main seal leak. Maybe I shouldn't have trimmed that little piece of rubber ridge off of it. It would have been a little bit tighter. I wouldn't be in this situation. I was angry because I had 7 full quarts in the pan. I was going to have to drain out, take the pan off, take the oil pump off, take the rear main off, put in a new seal, reseal it. I was just frustrated. So like an angry child, I kicked some rocks in the dirt, and then I put the engine away, and I just went in the house. I was angry. So once a couple days later, once I calmed down, came back out, and I cleaned everything off with brake clean, and I ran the prime again, and I just sat there and I slowly counted to 60. I wanted a good full minute of the pump running. It was longer than I'd run it before. And I came down and looked, and there was 1 drop right at the bottom. So I looked real close, and I'm like, oh, it's not coming from the rear main at all. It's coming from the back of that oil pan seal. And that is when I noticed, this is some of the issue with aftermarket stuff when you get it. So I noticed that the amount of gap in between the pan and the seal, when it got right here to the bottom, it looked like it was just, the gap was too wide. So what I did was used a rubber mallet, a little bit of persuasion, and what I did was I went around and I just tapped real lightly and I closed that gap up. So I think what was happening was there was some either backsplash or something from the pump running, and it was just washing up and coming out that seal. And there was a gap in the pan and the seal. It wasn't just wasn't squishing the seal tight enough to get a good seal. So once I did that, and I was confident that I'd close that gap up, washed everything down with brake clean, blew dry everything out, and then I ran it again for a full minute, and it's bone dry. So I told my buddy that I was going to have to tear it apart and put a rear main seal in it. I actually even I ordered another seal, so that's coming in the mail, so I'll just have an extra one. But yeah, it turned out to be for naught, and everything looks good. All right, that's one more thing down. Very, very close to putting it in the car. Now is the time to subscribe as well. You don't want to miss out, because once the engine and the drivetrain gets in, I think I'm going to body work, which is going to be interesting because I've never done that before. So the only skill I have is from watching YouTube videos. So that ought to be interesting. But anyway, I'm going to do it. I just hope I don't waste a bunch of money and then end up going to a body shop anyway. I hope not. We're going to find out. Anyway, like I said, good time to subscribe. Okay, so what is left to do? I got to pull the accessories back off the front. I can't fit the flex plate on with this engine stand, so it's going to have to come off of the engine stand so I can put the flex plate on, because I want to bolt the starter motor up and then check my clearances on the starter gear to flex plate. Just make sure all that's right and shimmed out. I'd rather do it on the stand out here. Well, not on the stand because it won't fit, but I'd rather do it out here than on my back in the car. So, and then once that's done, torque converter goes on, transmission gets bolted up, it goes onto the hoist, zip, swing into the car, bolt it up, and then I order a drive shaft once I measure it out. And once that's done, then I got to move on. I at least got to paint the jambs out all the way around to be able to get all that painted and then put the dash back in. And if I put the dash back in, then all I got to do is build my wiring harness and I could literally start this thing up, which is very tempting. I'm going to try to be a good boy. I want to get on the body work, but we'll see. Anyway, I'm thankful that you're here. I'm glad you're following along for those who are. And if you've reached out to me and asked a question and I've gotten an answer back to you and you're not subscribed, it's a good time to help your boy out. So anyway, that is all I got for now. Boy, this is going to be a sad video at the end, I thought, because I was going to have to say that I needed to tear it back apart to replace the rear main seal. And now I don't. Now that doesn't mean when it goes in the car and I have it running and take it on a test drive and come back and drive it around and come back, that it's not going to leak. This is 1970s technology. It's a two-piece oil pan gasket with rear seals. The nice one-piece gasket you see on LSs and all that stuff really makes it easy for it not to leak. But it's an old car. It's supposed to leak, right? Anyway, that's all I got. So this is Hutch from Hutch High Perf. Thank you so much for being here, and I hope you have a pleasant day. Take it easy.